Good evening, everybody. It is once again Ted the Speed Learner. We're going to go on with our commentary on Euclid Book 7 definitions. Okay. The next one is similar plane and solid numbers are those which have their sides proportional. What does that mean? Okay. Well, these are two planes, okay? I know they look like two rectangles, but they are planes because they don't have a third dimension. Okay? Now, they have to have their sides proportional. In order to understand that, you have to see the unit squares. Okay? We're going to pretend here that these unit squares are 1 inch by 1 inch. Okay? Which would actually make this whole line 6 inches long and this line here 3 inches long. Okay? So, and we're going to do the same thing over here. All these unit squares here are going to be 1 inch by 1 inch. Okay? And so that's going to make this line 4 inches and this line 2. Now, according to the definition, it says, similar plane and solid numbers are those which have their sides proportional. Okay. Well, these are plane numbers here because they come off of a physical plane. Okay? Now, as 6 is to 3, so is 4 is to 2. And you could go likewise. As 2 is to 4, so is 3 is to 6. Because 2/4 is really 1/2, and 3/6 is also 1/2. So, the sides about these plane numbers are proportional. And you can also visualize this by unit squares. There are 3 unit squares here. There are 6 unit squares here. 1, 2, 3, 4, 5, 6. Alright? So the proportion of the unit squares in this part of the plane to this part of the plane is the same as the proportion of these unit squares here to this one here. See what I mean? And that way you can actually visualize what's going on here. Now, what is this down here? Well, let me read that to you. A perfect number is that which is equal to its own parts. Now, what does that mean? Well, the parts we're talking about here are factors. The numbers 1, 2, and 3 are factors of the number 6. Now, if you add all those factors together, 1 plus 2 plus 3, you get the number 6. Because 1 plus 2 plus 3 is 6. So if you factor out a number completely and find all of its factors and then sum up all those factors and they become the number that you just factored out, then you have a perfect number. Same down here. We have 1 plus 2 plus 4 plus 7 plus 14. 28 can be divided by 1, and it can be divided by 2, it can be divided by 4, it can be divided by 7, and it can be divided by 14. Because after all, 14 times 2 is 28, and 7 times 4 is 28, and of course you can divide 2 by 28 and get 14, and of course you can divide 28 by 1. So if you add all these numbers up, 1 plus 2 plus 4 plus 7 plus 14, you get 28. There are only a few numbers in the universe that actually work out this way. That's what makes them so unique. And that's what Euclid was defining. Okay. Well, that concludes all of Euclid Book 7 definitions. I hope you've enjoyed my presentation so far. Get ready, folks, because we are going to cover Euclid Book 7, Proposition number 1 really, really soon. Then we're going to take you into some higher level of mathematics. And don't think I'm not going to take you there, because I'm going to. I will tell you more in a future video, so stay tuned.